Good morning, this is Mr. Veron with the solution to Thursday's problem of the day from May 7th. So it said, Hannah drew the triangle shown below. Part A, what is the total number of lines of symmetry that the triangle appears to have? Show or explain how you get your answer. Part B, draw a quadrilateral that has exactly 2 lines of symmetry. Draw the lines of symmetry. In Part C, draw a quadrilateral that has more than 2 lines of symmetry. Draw the lines of symmetry. So if we look at our solutions, so for part A, for our triangle that we had, if you see here, I drew one line of symmetry. So this is what we call a vertical line of symmetry. Now, in order to be able to do this, you need to know what symmetry means. So symmetry means I can cut the figure into 2 congruent parts. And here's the other key. I need to be able to fold it over this line, and it needs to be able to match. It's basically like a mirror image of each other. So if you can't fold it over and it matched, then there's not a line of symmetry, because you'll see later that we can cut it into 2 congruent shapes, okay, but we also need to be able to fold it over that line and create what we call a mirror image. So in this case, we have one vertical line of symmetry for the triangle. Now part B said draw a quadrilateral that has exactly 2 lines of symmetry. So in this case, I drew a rectangle. So a rectangle has a vertical line of symmetry. It also has a horizontal line of symmetry. Again, I'm cutting it into 2 congruent parts. So with our vertical line of symmetry, I have a congruent left side and a congruent right side. And also, if I was to fold this over, okay, it would match exactly, okay, it would create a mirror image. It also has a horizontal line of symmetry. So when I cut it this way, I have a congruent top and a congruent bottom. And again, if I was to fold it over that line, okay, it would match exactly. Then, when I get to the part C, it says, draw a quadrilateral that has more than 2 lines of symmetry. So, in this case, I drew a square. Now, in my square, I find that I have 3 lines of symmetry. So I have a vertical line of symmetry, so just like our rectangle, so it cuts into a left and a right that are mirror images. So again, I can fold it over and it will match exactly. It also has a horizontal line of symmetry, so we have a congruent top and bottom, and again, I can fold over that line and it matches exactly, creating a mirror image. And in a square, I also have a diagonal line of symmetry. Now, I could have done a diagonal this way, or I could have actually done a diagonal that way. And either way, once I do that, I have a congruent triangle here, which is congruent to this triangle here. And also, if I fold it over, okay, it will match exactly. Now, a lot of people say, well, why doesn't a rectangle have a diagonal line of symmetry? So if I was to cut the rectangle diagonally, I would end up with 2 congruent pieces. So that triangle that would be over here, okay, would be the same as the triangle that would be over here. However, I also said that it needs to be a mirror image of itself or be able to be folded on top of each other. If you were to take a rectangle and try to fold it, it would not match up. So therefore, there are no diagonal lines of symmetry, okay, on a rectangle. But in a square, we have vertical, we have a horizontal, and we have a diagonal line of symmetry. So hopefully you got the same answer, and stay tuned for today's problem of the day. Thank you. Bye.